All right, good morning, guys. This is 7.5 Trig Functions. 7.5 Trig Functions. So, since it seems like it's been a while, I want to kind of take you through what we've done so far in Chapter 7. We began by looking at special right triangles. And the reason we looked at special right triangles was because that's what made up the unit circle. And then we talked about how to use trig and inverse trig to find different sides and angles. We then created the unit circle and learned how to move from units to radians and radians to degrees. I encourage you to have your unit circle out for this lesson and for any subsequent lessons we do. So let's take a look at that special right triangle on the unit circle over here. Oh, sorry, get rid of that. We got a 30, 60, 90 triangle. And you'll remember that we got this point right here, that root 3 half, 1 half. We got that point right there because this side of especially the bottom side, the base of this 30, 60, 90 right triangle is going to be root 3. I'm going to try my best here. Root 3 over 2. And this side of the triangle was 1 half. That's not too bad. So this side here was root 3 over 2, and this side here was 1 half. So the x value was how far we went over on the x-axis, root 3 over 2, and the y value is how far we went up, which was 1 half. So today we are going to evaluate these different angles. We're going to analyze them using sine, cosine, and tangent, using SOHCAHTOA. So you'll remember that SOHCAHTOA stands for sine is opposite over hypotenuse, cosine is adjacent or next to over hypotenuse, and tangent is opposite over adjacent. So let's say we're looking for the sine of this triangle. We're looking for the sine of angle 30. Well, sine would be opposite side over hypotenuse, which is, opposite is 1 half, hypotenuse is 1. Well, what's 1 half divided by 1? It's 1 half. So the sine of 30 in this case is 1 half. Do cosine. Cosine is the same thing as adjacent over hypotenuse, which is root 3 over 2 over 1. Root 3 over 2 divided by 1 equals root 3 over 2. So you don't have to do this every time because there's a little shortcut that we can use for the unit circle. You'll notice that sine is 1 half, and that's the same as the y value here on this point, root 3 over 2, 1 half. So sine is the y value. Cosine is root 3 over 2. Wait, let me repeat that. I'm going to make sure I just said that right. Sine is 1 half, and the y value of this point is 1 half. Cosine is root 3 over 2, and the x value here is root 3 over 2. So I'm going to come over here to this chart, and I want you guys to copy this chart into your notes. So pause it and go ahead and copy this chart, and once you finish copying it, go ahead and press play again. Okay, so now that you've done that, we're going to copy all the trig functions into this chart. So we've got sine can be more easily stated as, we're not going to worry about that for this one. That will come in later. But when found on the unit circle, instead of having to evaluate opposite over hypotenuse every time, it's just the x value, the y value on the unit circle. Same with cosine. It can't be more easily stated. We will do that later. But cosine is the x value of any point on the unit circle. So now we're going to come back and look at this triangle, and we're going to do tangent. So tangent, you'll recall, is the opposite over the adjacent. So if we look at 30 degrees and we say, okay, well, what's opposite 30 degrees? Opposite of 30 degrees, the opposite side of 30 degrees is 1/2. And the adjacent side, what's next to 30 degrees, is √3/2. Now, where have we seen 1/2? Where have we seen √3/2 before? Well, it's the points. It's the point there where that special triangle touches the graph, but it's also 1/2 was sine and √3/2 was cosine. So coming back over to my chart, tangent can be more easily stated as, I'm going to make this an equation here, hang on. Tangent can be more easily stated as sine over cosine. So when we're looking for it on the unit circle, if I ask you for tangent of any part of the unit circle, instead of having to evaluate opposite triangle side over adjacent, you can just say it's the y value, whatever the y value is there, over the x value. So tangent, just to reiterate, tangent can be more easily stated as sine over cosine, and when found in the unit circle, it's just y over x. Now, this 1/2 √3/2, that's not simplified, so we're going to have to simplify that by multiplying by the reciprocal. So I've got 1 divided by 2 over √3 divided by 2. So remember, we take the bottom fraction and we flip it. So that's going to be 1/2 times 2 over radical 3 equals 2 over 2 radical 3. Now you'll remember we can't have a radical in the bottom, so we're going to multiply both the top and the bottom here by radical 3. And that's going to give me a second, let me clear some of this out. It's going to give me 2 radical 3 over 2 times radical 3 times radical 3 is just going to be 3. So that's going to give me 2 radical 3 over 6, which will simplify. The 2 and the 6 will simplify to 1 radical 3, or just radical 3 over 3. So the tangent of 30 is going to be radical 3 over 3. Now, that's a lot of math, right? Like, this is a lot of math, but this, you'll get really used to this because we're going to be doing this a lot for the unit circle. So those are the 3 basic ones that every student learns: sine, cosine, and tangent. But there are actually 3 more, and we're going to learn those today as well. And the first one we're going to learn is secant, or SEC. I'm going to go ahead and put that in this chart here. Now, secant is the same thing as 1 over cosine. So when you put it into, when you're looking at it on the unit circle, remember cosine is x, so whenever I ask you for the secant of an angle, you can just look for 1 over whatever the x value is. So let's come over here, and let's actually, you know what, I'll give you some time to look at that. So let's say that I ask you for the secant of 30 degrees. Well, we know it's 1 over the x value, so it's going to be 1 over √3/2. We can't have a radical in the bottom, so we're going to have to do some math here to simplify that. So 1 over √3/2. We're going to take 1, we're going to multiply it by the reciprocal, which is 2 over √3. That's going to be 2 over √3. You cannot have a radical in the bottom, so we're going to multiply both the top and the bottom by radical 3. That's going to give me 2 radical 3 over 3. And that's going to be secant. And if secant is 1 over cosine, then the other one we're going to learn is called cosecant, or CSC. And I'll bet you can guess what that is. That's going to be 1 over sine. And whenever I'm looking at it on the unit circle, it's going to be 1 over whatever the y value is. So if I'm coming over here and I'm evaluating the cosecant of 30, that's the same thing as 1 over the y value. So it's going to be 1 over 1/2. And just like secant, we want to simplify that because we don't like fractions and fractions. So 1 over 1/2 means I flip the bottom. So it's going to be 1 times 2 over 1, which is just going to be 2. So the cosecant of 30 is 2. And the last one we're going to learn is cotangent, which is COT. And if tangent is, if you look up there, it can be more easily stated as sine over cosine, then cotangent can be more easily stated as cosine over sine. Or, when we're looking at our unit circle, cosine is the same thing as x, sine is the same thing as y. So cotangent can be more easily stated as cosine over sine, and when you're looking at your unit circle, it's whatever your x value is divided by your y value. So let's go over here. Well, go back, take a look at that again. Let's come over here now. And let's do the cotangent of 30. We know that it is x over y, your x value over your y value. So my x value is root 3 over 2. My y value is 1/2. Fractions in fractions, so we're going to do some math here. Root 3 over 2 divided by 1/2. We flip the bottom and multiply it, so that's going to be 2 over 1. I'm going to get 2 root 3 over 2. Those 2's will cancel out, and you're just left with root 3. And we can leave something in a radical, we just can't leave radicals on the bottom. So now you know the 6 trig functions and how to evaluate the 6 trig functions on the unit circle. So let's continue with a little more practice. But before we do that, I want to come back here and I want to give you all some helpful hints, because in a perfect world, if we come back to class, you're going to have to memorize these. You're going to have to evaluate the unit circle and memorize sine, cosine, tangent, secant, cosecant, and cotangent. So I want to provide you with some helpful hints to remember those. The first one is remembering the difference between tangent and cotangent, right? Which one's sine over cosine, which one's cosine over sine. Cotangent starts with C. So it's cosine over sine. Since cotangent starts with C, cosine is going to go on top. And tangent's going to be the other one. Tangent is going to be sine over cosine. So basically cotangent starts with C, cosine on top. The second hint is that you want to believe that, if secant starts with S, so you think it would be 1 over sine. Oops, sorry. Tangent. Anyway, where was I? Oh my goodness, I do not want a header. Let's just do this. Anyway, secant starts with S. Cosecant starts with C. So you want to believe that secant's 1 over sine. Oh, cosecant's 1 over cosine, but it's not that. They have the opposite trig functions. So secant is 1 over cosine. Cosecant is 1 over sine. You want to believe that the letters would go together, but they don't. And this is the part where I say, ultimately, guys, math is a language. It's not necessarily learning the numbers. And all of these trig functions, sine, cosine, secant, cosecant, it's just different ways mathematicians have created to evaluate and analyze triangles. And so, it would have been a little bit nicer for them to do that for us, but they didn't. So that is the way of it. So basically, cotangent, cosine over sine, tangent, sine over cosine, secant, 1 over cosine, cosecant, 1 over sine. You just got to know those. All right. So let's do another example where we evaluate the 6 trig functions for pi over 6. Actually, we did that already. We did that for all of the, we did that for 30. Now, I could ask you again for radians. I could say, evaluate the sine of 5 pi over 6 or 7 pi over 6, and you'd have to look at your unit circle and do that. So we're going to go ahead and skip this example since we already did that. We're going to go down here to example 2. I like this one. It says, given the trig function below in the 4th quadrant, and that's very important. All right, that's very important right there. Can I do? Oh, I can draw. Heck yeah. Can I make my dot small? I can. Sweet. All right, so I'm going to circle that. In the 4th quadrant, determine the following. It says cosecant of theta, some angle, right? Theta, some angle or some radian, equals -2 root 3 divided by 3. Okay? So the first thing I'm going to do is it wants me to find the angle we're working with. It wants me to find which angle we're working with. And it's going to be hard to tell that based just off cosecant because cosecant is not on your unit circle. If you look on your unit circle, you don't have cosecant there. But I do know that cosecant is 1 over sine or 1 over y. And I can set that equal to -2 root 3 divided by 3. And now, this is just an equation. This is just an equation, and I can solve this by cross multiplying. So I'm going to get 3 times 1 equals -2 root 3 times y. And then to get y by itself, I'm going to divide both sides by -2 root 3, -2 root 3. And we're working with a small space here, so you're going to have to excuse me. I'm going to be deleting a lot. So that leaves us with 3 divided by -2 root 3 equals y. And that doesn't help us out much because that's still not on your unit circle. But remember, we can simplify. We have a radical in the bottom and we can't have a radical in the bottom. So we're going to take 3 over -2 root 3. And we're going to multiply both sides by root 3, or rather top and bottom by root 3. So I get 3 root 3 over -2 times 3, which is 6. So I get 3 root 3 over -6. Almost there. And that's going to simplify. 3 over 6 will simplify to 1 over 2, so it'll be -root 3 over 2 equals y. So if we look at our unit circle in the 4th quadrant, where do we have a y value that is -root 3 over 2? Go ahead and look at your unit circle. Try to find that yourself. Where do we have -root 3 over 2 in the 4th quadrant? Well, that happens at theta equals 5 pi over 3 or 300 degrees. Same thing. All right, so we set, given cosine, we set that equal to 1 over y, and we solved for y, and that told us what angle we were working with. Part B there says find tangent of that angle. Well, we're finding tangent of 300, or tangent of 5 pi over 3. So tangent equals, let's see, it's sine over cosine, so y over x. So if I look at my unit circle, my y value is going to be negative root 3 over 2. My x value is going to be positive 1/2. And I know that I'm going to do it in this box over here, guys, but I want you to write small and do it in that box over there. I'm kind of limited by how much room I have. So negative root 3 over 2 divided by 1/2. We're going to move that over here. We're going to multiply the bottom, multiply by the reciprocal. So I get negative 3 over 2 times 2 over 1. I get negative 2 root 3 over 2. Those 2's are going to cancel out, leaving me with negative root 3. So the tangent of 300, or the tangent of 5 pi over 3, is going to be negative root 3. So on the homework, you are going to be working a lot with these trig functions. You're going to be analyzing with stuff like this. I'm going to put that homework in the folder here shortly, and if you have any questions, let me know.